Okay, hi guys. So in this lecture, we'll be starting off with oxidation reactions. Okay, so let me write down the topic first. Okay, so in oxidation reaction, first we'll be seeing. Let's say we have alcohol and we have 1 degree, 2 degree, and 3 degree alcohol. 1 degree being simple ROH, or let's have RCH2OH. 2 degree we have like this, and 3 degree we have something like this. And now we have good oxidizing agents like this is PCC full form is palladium chlorochromate. We have Cr2O3 in presence of CH2Cl2. We have copper at 300 degrees Celsius, and then we have these were the mild oxidizing agents. Now we are having some strong like KMnO4, K2Cr2O7, and H2Cr2O7. These are strong oxidizing agent. Let me write it like this: strong and mild. Okay, so what will the products formed in this case? It would be RCHO in this case, in case of mild oxidizing agents, and in case of strong oxidizing agents it would be RCO2H. Okay, in what happens in 2 degree alcohol, it would be ketone in all the cases, because that's the last possibility left. Further oxidation will not yield anything even if strong oxidizing agent come into the picture. With 3 degree alcohol, only elimination can happen because it is having high temperature. Rest oxidation will not happen. Okay, now let's see some examples. We have something like this, N plus HN. We have something like Cr2O3 attached here. Okay, so this is also just for the information sake, very good oxidizing agent. Okay, and let's see what actually happens in when we react our primary alcohol with with a strong oxidizing agent, or with a mild first. So what actually happens is minus H2 takes place. Okay, and we get RCH double bond O. Okay, so first, by writing rightly minus H2, what actually happens is we provided H plus, or rather OH minus. So what actually happens is it will attack on this carbon atom, and as a result we'll be getting something like H plus would be released in this step, and we'll be getting something like this on water dehydration takes shape the form of a aldehyde. Okay, so this formed aldehyde would again go into forming on oxidation. Okay, so again we'll provide something like OH minus, and H plus would be released in this step. H plus would be released, and as a result we'll be getting something like this on oxidation. This is the process of oxidation. Okay, next let's talk about something like this. that how it actually happens. On further oxidation of this, we'll be getting OH here also. Just introduced OH, so we'll get OH, and then what will happen is CO2 gas will evolve. Okay. Okay, this will take place and the water molecule will be actually removed from the compound. Let's now talk about MnO2. MnO2 is also a good oxidizing agent, and let's understand this with the help of example. We have OH and OH here. In presence of MnO2, what will happen is, or what actually happens is, we get something like this. Okay, let's take a look at another example. We have primary alcohol. In presence of MnO2, it will be converted into RCHO. Okay, if we have something like MnO2 here, and again it would be getting oxidized here. Okay, so MnO2 is a mild oxidizing agent and is used for oxidation of allyl and benzyl alcohol only. Okay, so just writing this point that mild oxidizing agent and is used for oxidation of allyl and aryl, or rather benzyl alcohol only. Okay, oxidation of alcohol is also known as dehydrogenation. Okay, so another point is 3-degree alcohols will not undergo oxidation due to absence of alpha hydrogen. Will not undergo oxidation due to presence of alpha hydrogens, due to absence of, rather not presence of, due to absence of alpha hydrogen. Okay, so if you look at this step, oxidation of alcohol is also known as dehydrogenation. So this was a secondary alcohol in our case. So what actually happened in this compound is just the dehydrogenation happened, and as a result we got something like this. Okay, similarly this we also got something like RCH2OH. Again, what actually happened is this got dehydrogenation happened in the primary alcohol in presence of mild oxidizing agent, hence aldehyde was formed. And in case of 3-degree alcohols, no alpha hydrogen was formed, so no oxidation was took place in this case. Okay, So I hope you also got the point that in the MnO2 case, mild oxidizing agent and will only use for oxidation for allyl and benzyl alcohol only. So in this case, allyl alcohol was this one and benzyl was this one. Okay, and this was a simple aryl alcohol, hence oxidation of this group will not take place. This was a benzyl alcohol, it will take place. It is a allyl alcohol, it will take place. It is a benzyl alcohol, or sorry, aryl alcohol, it will not. Alkyl alcohol, it will not take place. So this is alkyl, this is allyl. Similarly, this is again benzoyl, this is also benzyl, and this is alkyl. So oxidation for allyl and benzyl take place, but alkyl does not take place. Okay, in presence of mild oxidizing agent MnO2. Okay, so last point to mention here is that formic acid is the only acid which easily undergo oxidation due to presence of formyl like group. Okay, so last point is formic acid is the only acid which undergoes oxidation due to presence of formyl like group. Okay, because if you see the structure of formic acid and formaldehyde, so it is a formyl like group, hence oxidation happens easily compared to other acidic groups. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more on the oxidizing and reducing agents. So till then, good luck and goodbye.